All right, I accidentally clicked stop instead of pause, so I have to separate this into two videos. But what I intended to do was finish up this last problem on the back of the homework here. Okay, so in this problem, instead of having just one value to graph, I have a whole table of values to graph. This is a unit of time, years, and also the top row of data is usually X. So we're going to do years across the bottom of the graph. My highest years value is 10. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, we just make it. We can count by ones. Okay, now that means the y-axis is going to be our total height. Okay, now our highest number there is 130. So guys, counting by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Ah, we're not going to make it. So let's switch to 20s. 20, 40, 60, 80, 120, 200 when you get to the top. Then I'm going to start graphing this. At 3 years, it was 39 inches. Okay, the tree at 5 years was 65 inches. Must be kind of a small tree. At 6 years, 78. At 8 years, skip over 7, 8, it's at 104. And at 10, it's at 130. Now what you should notice is that we're estimating the location of the points because we're not computers. We're estimating the location of the points because we're in between values. But they roughly form a straight line. And that line should connect back to the origin. If no time has gone by, then the tree has not grown. Connect them, put an arrow. Okay, so that's your graph. Now it said calculate the growth per year. Here again, these decode your words. They help you determine what to divide to get your rate. You can pick any group, any pair of numbers. The growth was 78, the year 6. And 78 divided by 6 is 13. Now, I didn't have to pick that column. If I'd picked 39 and 3, the first one, well, I'd have smaller numbers to deal with. That might be easier. But 39 divided by 3 is also 13. So it doesn't matter. You're just calculating the rate based on one column's worth of numbers. Okay? Write the equation for the graph. Well, the height, which is on the y-axis, is 13 inches for every year. How tall will the tree be after 14 years? Well, if it grows 13 inches every year and 14 years go by, 13 times 14 is 182. Again, very important that you write down the 13 times 14 step, even if you did it in your head, even if you typed it onto a calculator, okay? You have to write down what you did to get the answer. Okay? I want to help you set up the next graph only, and you can do the rest yourself. But setting up the graph seems to be the hard part for people. Okay? Days, number 6. The following table represents the number of days that Olivia read each night and the total pages. Okay? So, again, X is the top row, both because it's the top row and it's a unit of time. The y-axis is going to be total pages read. So days. and our highest value is 9. Well, we just did 10, so we know that that will fit counting by ones. Here my highest value is 135. Well, in the previous question we just figured out that counting by 20s would fit, so we'll count by 20s again. I will tell you that on a Regents exam or your state test, they usually give you an optimum number of squares. So if you find yourself squishing your graph into one small corner, or if you find you have to draw extra boxes, you're not planning out your graph correctly, okay? You don't have to use every square, but a good rule of thumb is try to use more than half the space, okay? 2 and 30, 5 and 75, 7 and 105, 8 and 120, 9 and 135. And roughly, connecting back to the origin, if no time has gone by, then she has not had any total pages read, which I've forgotten to label over here. Total pages read. Okay? Don't overthink these labels. They're the same thing as what the labels are in the boxes. And an arrow. Okay? The rest of this I expect you to do on your own. Take the rest of the class period and finish this assignment. Or if you're looking at this from home, thank you for watching and have a good day. See you next time.